Fructose is a monosaccharide found in many fruits and is often called fruit sugar. Similar to glucose, it is absorbed directly into the blood as we digest fruit. Fructose has 6 carbon atoms and 5 OH groups, like glucose, but instead of an aldehyde carbonyl group, it has a ketone carbonyl group. Recall that ketone groups, like the one on fructose, are carbonyl groups within a hydrocarbon chain. Aldehydes, in contrast, are carbonyls at the ends of a chain, like the one on glucose. Because of this difference, the ring closure reaction of an acyclic fructose produces a 5-carbon ring. Like other monosaccharides, fructose exists in both the acyclic form and cyclic form. Let's learn how to draw the cyclic form of any ketohexose from the acyclic form by using D-fructose as an example. To start, we need to identify which of the 5 OH groups in D-fructose is at the right distance from the carbonyl group to form a 5-membered ring. This OH group, circled, is the right distance away from the carbonyl to form the 5-membered ring. To convert this acyclic form into a cyclic hemiacetal, rotate the molecule 90 degrees. Note that the groups that were on the right side of the molecule are now below, facing down. Next, wrap the OH group on carbon 5 up close to the carbonyl, as shown here. In the process of doing this, the CH2OH group at the end of the chain ends up above the molecule, facing up. We are now ready to close the ring. The OH group on carbon 5 and the carbonyl carbon form a new carbon-oxygen bond. In the process of forming this bond, a new chiral center is produced. The new OH group is either up or down. The alpha anomer of fructose, called alpha-D-fructose, has the OH group on the anomeric carbon facing down. The beta anomer, called beta-D-fructose, has the OH group facing up. Haworth projections are useful for drawing and representing cyclic monosaccharides in 2 dimensions, but it is important to remember that the rings are actually not flat in 3 dimensions. This 3-dimensional structure illustrates the non-planar structure of cyclic monosaccharides.